Hi students, this is Ms. Johnson with 9-1 Graphing Quadratic Functions. Our SWABAT for today is we are going to analyze and graph quadratic functions. Alright, first of all we need some definitions. And the first definition is a parabola. And a parabola is the shape of a quadratic graph. And it looks either like upside down, I should say an N or a U. So curved up or curved down. Second definition we need is what is the axis of symmetry? Well, the axis of symmetry is the line of symmetry in the parabola. It goes right in the middle, dividing the parabola in half. And the equation for how we find this is when we are finding x, where this is, where this axis of symmetry is, we're going to do negative b divided by 2a. So we need the a and b values of a quadratic equation. And our third vocabulary word, what is a vertex? Well, a vertex is the minimum or maximum of a parabola. And I have a couple pictures here. If the parabola is like an N curving downward, then that means this point right here is the maximum. On the opposite end, if the parabola curves up, then down here at the bottom, this point right here is the minimum. And that's where the vertex is, right at the top or the bottom. Alright, let's do some examples. Example number 1, we're going to use a table and graph to state the domain and range of y equals 3x squared plus 6x minus 4. And just a reminder, of course, the domain is the x values that's allowed, and the range is the y values. So step number 1 is we're going to make a table. And I would suggest picking 3 to 5 numbers that we're going to plug in for x, for our domain. So I'm going to make my table going across, just save some space. And I'm just going to fill in -2, -1, 0, 1, and 2. There's no rhyme or reason. I just always like to use 0, and then I want some negatives and some positives. Alright, so then what we're going to do is we're going to fill in -2 into our equation. Alright, so we're going to plug in -2 in for x. So we've got -2 squared, which is 4. 3 times 4 is 12, plus 6 times -2 is -12, and then minus 4. Well, positive 12 minus 12 is 0, so we get -4. Alright, let's do it again. This time let's plug in -1. -1 squared is 1, times 3 is 3, plus 6 times -1 is -6, minus 4. Now we get -7. Next is 0. Plugging in 0, 0 squared is 0, times 3 is 0, plus 6 times 0, which is 0, and then minus 4. Alright, that's easy. That's why I like using 0, because then it's just simple math, and you're always going to be left with this minus 4. Alright, plugging in 1. 1 squared is 1, times 3 is 3, 6 times 1 is 6, minus 4, and 9 minus 4 is 5. And one more, plugging in 2. 2 squared is 4, times 3 is 12, plus 6 times 2 is 12, 24 minus 4 is 20. Alright, so as I said, we just pick some numbers, some positives, some negatives, and a 0. Plug them into our equation. Alright, now step number 2 is we're going to graph our table of values. So I've got my graph set up. Alright, so let's see, my x is -2, so I'm going to go to the left, -2, down to -4, 4, there's my first dot. Next one, -1, -7, -1, 1, 2, 3, 4, 5, 6, 7, 0, -4, right in the middle, 1, 2, 3, 4, 1, 5, go across to 1, up to 5, 1, 2, 3, 4, 5, and then 220, go over 2, 20 certainly doesn't fit, it's probably way up here. Alright, so making a table, graphing the table that we just made, and then what we're going to do is when we graph this, we're going to connect the dots, and they look like this, but it's a parabola, so it's going to be same on the other side. So it's going to look something like that. Alright, so the domain is all the x values. Now when I made my table, could we have picked any x values to use? Absolutely. So the domain is always going to be all real numbers. And remember this from earlier, we're going to write them as the set of all real numbers x such that x is, and I probably should write, I could only type r. Remember, all real numbers is 2 lines with the r, and then we make the r with it. And then end your set. And the range. Here's how we find the range. The range is the y values. Let me switch my colors. The y values is what goes up and down. Well, if we take a look at our graph, this is the bottom of our graph. This is as low as we're going to go, and then the parabola is going to keep going upwards. So the range is going to start down here, and it's going to be our set of y values such that y, let's see, this is as small as it's going to be, and this was at -1, -7. So that means all of our y values are going to be bigger. So it's going to be y is going to be greater than or equal to -7. That point right down here at the bottom. All right, moving on to example 2. We are going to find the vertex, the axis of symmetry, and the y-intercept of each of these graphs. Okay, the vertex, just a reminder, is the maximum or minimum of each graph. The axis of symmetry is the line that splits the graph in half, and the y-intercept, of course, is where the graph crosses the y-axis. All right, graph A. If we take a look at this graph, we are going to first find the vertex. The vertex is right here. It's right where the graph is at the top. Okay, it is a maximum because this is as high as it goes, and this point is at -1, 1, 2, 3. So our vertex is at -1, 3, and we want to state that it has a maximum. All right, then we need to define the axis of symmetry. Well, the axis of symmetry is right where this vertex is. We can draw a dashed line right here. If I were able to fold the computer screen in half and flip it over, it would match up exactly right on that dotted line, or dashed line. So the axis of symmetry, the way that we label this, is we say it's going to be our x value when x equals -1. Notice -1 is the x value in our vertex point. And lastly, the y-intercept, where the graph crosses the y-axis. Well, our graph, this is the x-intercept. Our y-intercept is right here, and our y-intercept is when y equals 2. So our y-intercept is when x is obviously 0, and the y is 2. All right, why don't you pause the video and see if you can figure out part B on your own. Did you pause it? Did you figure it out? Your vertex should be right here down at the bottom. Okay, this is at 1, and then we have to go up 1, 2, 3. So our vertex is at 1, 3, and it's the bottom of the graph, so it is a minimum. All right, then using that point, our axis of symmetry is right here, this dashed line, and it's when x equals 1. Again, it's the x value in our vertex. And then the y-intercept, the graph crosses the y-axis right here, and it's when x is 0 and y is 1, 2, 3, 4. So we label the y-intercept as 0, 4. All right, so that's using a graph. Now we're going to find the axis of symmetry, the vertex, and the y-intercept using an equation. And we're going to use y equals 2x squared plus 4x minus 3. Just a reminder with quadratic equations, they are always set up in y equals ax squared plus bx plus c. And as I stated earlier in the vocab, the axis of symmetry can be found when, this should say x equals -b divided by 2a. All right, so first step is we're going to find our axis of symmetry. And the way that we're going to do that is we're going to use this equation, -b divided by 2a. Well, our b value is right here in front of the x. Right now it's 4, so -b is going to be -4 divided by 2 times a. Our a value is in front of the x squared, so it's going to be 2 times 2. All right, so let's see, 2 times 2 is 4, so now we've got -4 divided by 4, and so that means our axis of symmetry is when x equals -1. Okay, knowing that that is our axis of symmetry, we are going to use that x equals -1 to find the vertex. So if x equals -1, what we're going to do is we're going to plug -1 into our equation. And way we do that is 2 times negative 1 squared plus 4 times negative 1 minus 3. Alright, negative 1 squared is 1, so we've got 2 times 1 plus 4 times negative 1 is negative 4 minus 3. Continuing with our math, we've got 2 minus 4 minus 3, which of course is y equals negative 5. So our vertex is at negative 1, negative 5, which I have written as the coordinate pair right there. Alright, so we found the axis of symmetry, we found the vertex, now we need to find the y-intercept. This is probably the easiest one. Of course, the y-intercept is when the x value is 0, so we're going to plug 0 into our equation. And as we do that, 2 times 0 squared plus 4 times 0 minus 3. Well, the first one's 0, second part's 0, we just have minus 3. The y-intercept is negative 3. It's always going to be the constant term at the end. So the axis of symmetry is when x equals negative 1. Our vertex is going to be at negative 1, negative 5. And our y-intercept is going to be at negative 3. Alright, decide for your summary. Are you going to do it right now in your notes, on a summary sheet tomorrow, or in a foldable study guide? Thanks for tuning in. This was Ms. Johnson with 9-1, Graphing Quadratic Functions. We analyzed and graph quadratic functions.